All right, hey guys. This is my final question for Math Stats 1. This is question 12 off of the final. It's a beta distribution question. So just to lead off, our alpha is equal to 8 and our beta is equal to 2. For me, it makes a lot more sense when I can get context into things like this. So I did some research and I looked up some things and found that sports is a pretty good application of the beta distribution. So I'm going to go ahead and use free throw percentages on this specific problem. So with an alpha of 8 and our beta of 2, our goal is to determine the probability of a player finishing with a free throw percentage between 20%, 0.2, and 80%, 0.8. Now, the application of this would say that alpha is our successes and betas are the fails. So in this case, alpha equals 8 represents so far this player has made 8 free throws, and this beta is equal to 2 would represent so far this player has missed 2 free throws. So our goal here is once again to determine the probability that this player ends with the free throw percentage between 20% and 80%. Now, this right here is our PDF for the beta distribution. The first thing that we need to do is if we can figure out what this gamma is, this gamma function right here in front, that's going to help us simplify everything because this ends up being just a number. So if you look below, since alpha and beta are integers, the gamma function ends up being a factorial function, n minus 1. Thus, the gamma of alpha is equal to 8 minus 1 factorial, which is the same thing as 7 factorial. The gamma of gamma of beta is equal to 2 minus 1 factorial, so just 1 factorial. And then the gamma of alpha plus beta is equal to 10 minus 1 factorial, which is equal to 9 factorial. So if you I actually switched these on this side, but the gamma of alpha plus beta is 9 factorial. The gamma of alpha is 7 factorial. The gamma of beta is 1 factorial. So in the end, after all the cancellations, so 9 factorial with 7 factorial cancels out to just 9 times 8, which gets me 72. So the next thing we have to do is we're going to go ahead and put this in an integral because we need to collect all the probabilities up to the point in between 0.2 and 0.8. So what I did, I just took the gamma functions out of the integral because there are no x values there. So I'm able to just put it in front of the integral. And right here, this is where that 72 came from. My bounds are 0.2 and 0.8 because my lower bound is 0.2, 20%, and my higher bound is 0.8, which is 80%. So I'm just going to go ahead and use this PDF right here, or x is equal to alpha minus 1 times 1 minus x to the beta minus 1. So I substitute my value in for alpha, 8, and my value in for beta, 2. In the end, it turns out to be x to the 7th times 1 minus x to the 1st. We're lucky that's to the first power. It just makes this 1 minus x. So I distribute the x to the 7th to both of those terms. And I get x to the 7th minus x to the 8th. That's a pretty simple integral. So we're going to go ahead and simplify it to x to the 8th over 8 minus x to the 9th over 9th. Calculated from 0.2 to 0.8. I am really blanking on that word right now, but we're just going to go ahead and calculate it between the values of 0.2 and 0.8. This ends up being this number right here, 0.00605,818. And I'll multiply that by the 72 right here, which gives me a percentage of 0.436189. So in this slide right here, I go ahead and summarize my results. My conclusion is there's approximately a 43.6% chance that this free throw shooter has a free throw percentage between 20% and 80% at the end of the season. So this number right here, 43.6%, is just what the probability is that's between these two numbers. Let's think about what the results mean. So right now, the current mean is 80% because we have to take our successes divided by our successes plus failures. So 8 divided by 8 plus 2 is 80%. So that's going to make the probability of that near 50 because the current mean is 80. It is likely that the shooter also has a percentage above 80% too. So that's just my conclusion here. Noticing this, the center of the beta curve is near 0.8 right here. It's near it. It's not the highest point. The center of it isn't really exactly on it, but is pretty near this right here. And the likelihood of a shooter ending with a percentage greater than 80% is more than the likelihood of less than 80%. So what I'm looking at is this. From this point on, our PDF is more dense to the right than it is to the left, which makes sense because 10 free throws is not that much in the course of a season. And if someone's hit 8 out of 10, they're most likely a pretty good free throw shooter to begin with. So it's going to be pretty good probability that that player ends up with a free throw percentage above 80%. Well, thanks for watching this presentation.